what we are going to be doing in this video is we want to differentiate y equal k raised to power sine s from first principle. So we are going to be using first principle to differentiate what you can see on the screen, y equal k raised to power sine x. So before I start, I'm going to be telling you what I'm going to be using alongside with the proof. So that is what I have written there. So I said useful tools to use. That is what I'm going to be using, what I'm going to be needing while solving this question from first principle. Of course, this is from trigonometry. Sine A minus sine B equal to cos A plus B over 2, sine A minus B over 2. That is product formula. That is from trigonometry. And again, log to base E can be written as log or ln. So I'm going to be writing log in the solution, and then if I don't write any base, the base is exponential. So now again, this is from elementary limit of this is a standard limit as s goes to 0 of sine s over s. We know that the answer is 1. And again, when you take the limit as y goes to 0 of 1 plus y raised to the power of 1 over y, the answer will still be, the answer is exponential. These two are called standard limits. Now what you need to pay attention to in this case is the angle of sine, and what should be at the base must be the same. The angle here and what should be at the base must be the same before it can give 1. Similarly, what is inside the bracket here and what is at the power, the reciprocal of the power, they must be the same for this thing to give you exponential. So for the fifth one, I wrote this to refresh our brain on formula for first principle. That was the first reason. And the second reason is if y is a function of x, you have delta y over delta s to be equal to this. This is f of s plus delta s minus f of s all over delta s. Then you take limit as delta s goes to 0 of both sides. Similarly, why I wrote this again is because if s is a function of y, so in this case you will get delta s over delta y, then you write f of y plus delta y minus f of y over delta y. At the end of the day, I will take limit as delta y goes to 0 of both sides. I'll take limits as delta y goes to 0. So that is what we are going to be having. Let's come back and solve the main question. I have y equal k raised to power sine s. I'll take the log of both sides. I will have log y. Don't forget, I'm going to be using first principle. Is equal to log of k raised to the power of sine s. So from the law of logarithm, this is log y to be equal to this sine s. We can come to the back of log k. I will have log, then log k. This is from the law of logarithm. That is from the elementary. Now I will start introducing my increment. Don't forget, I'll first add increment. I will have a log, then y plus delta y, that is increase in y plus increase in y, is equal to, then I have sine s plus delta s, and that is increase in s. Don't forget, the log to base k is still multiplying it. So this is what I will have next. I will subtract log y from both sides. I will have a log, I have y plus delta y minus log y. I'm going to subtract log y from both sides, equals sine s plus delta s. I have log k minus, now don't forget log y. I'm supposed to write log y, but log y is sine s log k, so I have a minus sine s log k. So the next thing is from law of logarithm. Whenever you have log a minus log b, you have log a over b. So this one will become log of y plus delta y all over y is equal to, now log to base, log k is common, so I will be having in the bracket, in the big bracket, sign s plus delta s minus sin s log k. That is what I'm going to have next. So the next thing is I'm going to, this one will become, I'm going to write this as a single fraction, y over y. Y over y will give me 1 plus, then I have delta y over y as well. Then this one, from the product formula I showed you the other time, this one will become 2 cos. Don't forget, this one is like a, this is like a, and this is our b. Our a is s plus delta s, our b is s. So this one will become 2 cos s a plus b, don't forget, all over 2. Then I have sine s plus delta s minus s all over 2. The log k is still there, it has not cancelled out, so I have all over log k. So what will happen after that? This one will become log of 1 plus delta y over y is equal to 2 cos, is equal to 2 cos 2s plus delta s all over 2. Then I have sine s minus s will give me 0. I will be left with delta s over 2. So log k. That is what I'm going to have now. So after that, don't forget, the next thing is to divide through by delta s. So I will divide through by delta s. This one will become 1 over delta s log of 1 plus delta s all over y is equal to, all these ones 2 divided by delta s, but I'm going to write it this way, 2 cos. Now I'm going to make this as a single fraction as well. 2s divided by 2, I will have x plus delta s over 2. If you find the LCM, you will get what is on top here. Then I have sine delta s all over 2 log k. So now if you look at the left hand side very well, you will see that left hand side before I divided by delta s is a function of y. It's as if I make s the subject of formula. So at the left hand side I have a function of y, then at the right hand side I have a function of x. Why I'm telling you this is because by the time I want to take limit, you are going to see what I'm going to do, and it is very correct. Let's continue. Now after that, I know what I'm going to do now. Look at what I'm going to do. I have 1 over delta y multiplied by delta y all over delta y multiplied by y over y. Now delta y divided by delta y is 1. Y divided by y is 1. So 1 times 1 over delta s is still delta s. So I have not changed anything because they can divide themselves and the answer will be 1. So this is log of 1 plus delta y all over y is equal to, I forgot to divide this one by delta s. So this is all over, this is delta s. So this is equal to 2 cos s plus delta s over 2 sine delta s over 2 all over delta s log k. So now you can see what I have: 1 over delta s multiplied by delta y over delta y multiplied by y over the y over y log 1 plus delta y over y equal to cos s plus delta s all over 2 sine delta s over 2 all over delta s log k. So why did I put this? You might be thinking why I had to add these ones. So why I added this one is because I want to do something. Look at what I'm talking about here. I want to write, because by the time I take limit, I want to write this one with log in this form. I want to write that 1 over y everything raised to the 1 plus y everything raised to the power of 1 over y. That is what I want to do. So look at what I'm going to get at the left hand side now. I will take this delta y at the numerator. I'll take this delta y at the numerator to come to this place, so that I will have delta y all over delta s multiplied by, now nothing will be here. I will let this y come here, y all over delta y multiplied by 1 over y. I've just rearranged what is here, nothing has changed. So I have log of 1 plus delta y over y is equal to, now in this case don't forget, limit as s tends to 0 of sine s over s, the answer will be 1. So but here the angle here is delta s over 2, so I have to have delta s over 2 at the denominator, so I'm going to be using this 2 here. I will divide both numerator and denominator by 2, so that this 2 will no longer be there. I will just be having cos s plus delta s over 2, then I have sine of delta s over 2 all over delta s over 2. If you do the LCM here, or if you simplify this, you will see that these 2 can come here back, so it's still the same thing. Then I have log k. That is what I will have. So look at what will happen in the next thing. I will take this one, I will allow it to be raised to the power. I will have delta y all over delta s multiplied by 1 over y. That is what I still have here. Then this one will come to the power, since it's logarithm. This is just a basic law of logarithm. 1 plus delta y over y, then I have raised to the power of y over delta y is equal to cos s plus delta s over 2 sine, I have delta s over 2 or everything over delta s over 2 log k. That is what I'm going to have now. So the next thing I'm going to be doing, so now you can see what we are getting. So the next thing I will do is to take limit of both sides. Now at the left hand side, this is a function of y, so I take limit as the y delta y goes to 0. At the right hand side, this is a function of x. I take limit as delta s goes to 0. So what am I trying to say? So here I take limit as delta y goes to 0 on the left hand side of all these things you have here of delta y, this multiply by 1 over y multiply by log of 1 plus delta y over y. Then this one I can write it as 1 over delta y over y. 1 over delta y over y is the same thing as y over delta y, so it's equal to limit as delta s goes to 0 in this case. So at the left hand side I take limit as delta y goes to 0, then on the left I take limit as delta s goes to 0. Of course, s plus delta s over 2, then sine I have delta s over 2 all over delta s over 2, then log k, log of k. That's what I will have. So now at the end of the day, if you look at the standard limit I gave above, don't forget, whenever you have limit as y goes to 0 of 1 plus y raised to the power of 1 over y, the answer is e. Limit as s goes to 0 of sin s over s, once the angle and what's at the denominator are the same, the answer is 1. So that's what I'm going to be applying here. So this one, whenever you take limit as delta y goes to 0 of delta y over delta s, this becomes this 1 over y does not contain any delta y, it's like a constant here. So I have 1 over y the y ds multiplied by the y ds. But you might be thinking, how? Don't forget, let me quickly show you something. Let me show you that delta y over delta s is actually same as 1 over delta s over delta y. So whenever you have whenever you take limits as delta y goes to 0, you'll be getting 1 over ds dy, and ds dy is equal to dy over ds. So that is for this case. So that is why I could easily get dy ds in that place. So for the next one, so let's continue now. I have when you take limit as delta y goes to 0 of this, of all this here, this one will be log of e is equal to, now for cos s plus delta s, this is as delta s goes to 0, this one will be cos s plus 0. Then when you take limit of this one will be multiplied by 1 multiplied by log k. So at the end of the day I have 1 over y dy ds log to log e base e. Don't forget, this is log to base e. Log e base e is 1, so that's 1 is equal to, this is cos s plus 0 is still cos s, then log k. So the next thing that will happen is the y ds we have to be equal to cos s multiplied by y multiplied by log k. So you can leave your answer like this, or you write what y is. This is equal to cos s, then y is k raised to the power of sin s log k. So this is our final answer. That is the answer to that question we solve, and this is by first principle. Please kindly subscribe to my YouTube channel. Thank you very much. And I also have a question for you to solve. Try this one from first principle. Try this. Y is equal to e raised to the power of square root of s. Try to solve this from first principle. So if you don't get the answer, you can check my video, or if you want to see how to solve y equal e raised to power square root of x from first principle, the link, you would have seen the link on the screen, so just click. But make sure you try your hands before you check out the video. Thank you very much.